Hello, hi, welcome to the student. This is our Shiva sir. Today we are going to discuss about light reflection and diffraction. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Okay. So when light incidenting on the surface, so it reflect back. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is deviated, that is called undeviated line. Okay, so normally our initial direction of the incident ray. So now I am considering here. So plane surface. The light ray which is incidenting on it. So this is incident ray. And this one is the reflected ray. Incident ray. Incident ray. Reflected ray. Reflected ray. And the line which is perpendicular to the surface is called normal line. The light ray which is perpendicular to the surface is called normal line. And so this is the undeviated line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the angle between reflected ray and undeviated line is called angle of deviation. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. And here laws of reflection. So we have to discuss about laws of reflection. Laws of reflection. So what are those laws of reflection? So angle of incident is equal to angle of reflection. First point is angle of incident or incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Second one, angle of incident is equal to angle of reflection. Okay. So incident, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. And so this is about laws of reflection. Reflection phenomenon is nothing but the bouncing back of the light from the reflecting surface. reflection of light. So reflection of light is nothing but the bouncing back of the light from the reflecting surface is called reflection of light. So the light ray which is incidenting on the surface is called incident ray. This is the incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line. Okay. So incident ray, reflected ray, normal line lies on the same plane. And second point is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. And next one, here we can take linear angle. Linear angle is 180 degrees. Linear angle is 180 degrees. Okay. So according to that, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation from this. So we can take angle of reflection plus angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. We can take like that. Okay. So we can consider. I hope it is very clear. Okay. Now I hope it is very clear. Angle of incidence plus angle of reflection plus angle of deviation equal to 180. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So this is about completely about reflection of light. Okay. So next one we will discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. So incident parallel beam. So reflector light rays. Reflector parallel beam. Okay, so here you have to observe one thing. So incident beam is parallel, then reflected beam also parallel. Okay, so now, so where you can observe this regular reflection. This is about regular reflection. Regular reflection. Regular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Coming to the irregular reflection. So incident beam is parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. So they will go in different directions. So now you can observe incident beam is parallel, but reflector light rays are not parallel to each other. So they'll go in different directions. So this is about regular reflection. Here, irregular reflection. So regular reflection takes place on smooth surface, still water, but irregular reflection takes place on rough surface. Okay, rough surface, wall, we can take. Now we will discuss about object and image. We'll discuss object and image. Light rays are coming from object. After reflection, the light rays are meeting at one point. So here is real object, sorry, real image. Light rays are coming from the object, right? This is a real image. And if you are extending these light rays, so this is a virtual object, real image and virtual object. Now, so here I am taking this is a real object, virtual image, real object and virtual image, real object and virtual image is virtual. So the point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays. So these are the reflector light rays. So you can consider here. This is incident 1, incident 2. So reflector ray 1, reflector ray 2. So here also same thing. Incident 1, reflector ray 1, incident ray 2, reflector ray 2. So we are extending. Okay. So we are here you can observe. We are extending the incident light rays. Extended incident light rays are meeting at one point. Their virtual object is formed. So here extending reflector light rays. Reflector light rays are extended. Their virtual image is formed. Here directly meeting. Directly reflector light rays are meeting. That's why it is called real image. Directly. So light rays are coming from object. So that's why this is a real object. Okay, directly from the object light rays are coming, that's why it is a real object. So directly reflector light rays are meeting, so the image is forming, that is a real image. Okay, next one. Nature of the image formed by the plane mirror. So now we will discuss about nature of the image formed by the plane mirror. First point is object is real, image is virtual. Object is virtual, image is real. Second one is, so here you can observe object distance is equal to image distance. Object distance is equal to image distance, and the height of the object is equal to height of the image. And coming to the fourth one, it also shows lateral inversion. It also shows lateral inversion. What is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So this phenomenon is called lateral inversion. Okay. So once again you can observe object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image. So it also shows lateral inversion. It also shows lateral inversion. Okay. So that is about. Next. Now concave mirrors. Concave mirror. Concave mirror. So spherical mirrors are two types. One is concave mirror and the one is convex mirror. So spherical mirrors. Concave I will draw. Concave mirror. Concave mirror. So here you see this is a concave mirror where reflection takes place inward. So after converging, the light rays will meet at one point on the principal axis. Concave mirror. Next one is convex mirror. Convex mirror. convex mirror. So after reflection, these light rays will be diverging. Okay, so those will meet at one point. So concave mirror is also known as converging mirror. Converging mirror. And convex mirror is also known as diverging mirror. Okay, concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. So based on converging nature and based on diverging nature, so we divided into two types. Okay, so now we will discuss few more. That is, so now we will discuss about terms related to spherical mirror. Terms related to spherical mirror. So check once here. Terms related to spherical mirror. So here I will take, especially here I will consider concave mirror. Here I am taking the concave mirror. So this is a part of the sphere. So the center of the sphere in which mirror is a part, center of the sphere in which mirror is a part is called center of the curvature. Because we are taking the small portion, that's why it is called curvature. Okay. So midpoint of the mirror is called pole. Midpoint of the mirror is called pole. And so I'm taking the concave mirror here. What type of mirror I'm considering? Concave mirror. Center of the imaginary sphere in which mirror is a part, pole. So the distance between center of curvature and pole is called radius of curvature. The distance between center of curvature and the pole is called radius of curvature. Radius of curvature. Okay, I hope it is very clear now. Check once. So the distance between center of curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. Okay. And fourth one, after reflection, all light rays will meet at one point on the principal axis. That is called focus. Focus. Okay. So now you can observe here. Center of the imaginary sphere in which mirror is a part is called center curvature. Midpoint of the mirror is called pole. The distance between center curvature to pole is called radius of curvature. So after reflection, all light rays will meet at one point. Okay. So that is called focus. And coming to the fifth one, the distance between focus to pole is called focal length. So this distance is called focal length. Focal length. And the sixth one, so central curvature, pole, radius of curvature, focus, focal length, and width of the mirror is called aperture. Width of the mirror is called aperture. Okay, so where reflection takes place, that width is called aperture. Okay, so center of the imaginary sphere in which mirror is a part, midpoint of the mirror is called pole. The distance between center curvature pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis is called focus. The distance between focus to pole is called focal length. Width of the mirror is called aperture. Okay, so these are the terms related to spherical mirror. Now, so we'll discuss ray rules of concave mirror. So 1 minute. So here you can observe these are the terms related to spherical mirror. Now we will discuss about ray rules. Ray rules of spherical mirror, concave mirror and convex mirror. So ray rules of concave mirror and convex mirror. Ray rules. So now you can observe concave mirror. Here concave mirror. Concave mirror. So pole, focus, central curvature, pole, focus and central curvature. One light ray I am taking. After reflection, the light rays are passing through. Light ray is passing through focus. Second one, so pole, focus, central curvature, pole, focus and central curvature. Light ray is passing through focus. After reflection, moves towards infinity. And coming to third one, so pole, focus, center of curvature, light rays passing through center of curvature. After reflection, retrace its original path. And coming to the fourth one, so pole, focus, center of curvature, pole, focus, and center of curvature. Light rays incidentally at the pole, so it will be reflected back. Okay, so these are the ray rules of concave mirror. Coming to ray rules of convex mirror. Convex mirror. So here convex mirror I am taking. So same, here I am taking convex mirror ray rules. So pole, focus, center of curvature. Light rays coming from infinity after reflection, it passes through focus. And coming to the second one, so pole, focus, center of curvature. Light rays passing through focus. So after reflection moves towards infinity. Coming to third one. So pole, focus, center of curvature, pole, focus, and center of curvature. Light rays incidenting through the center of curvature. So it will passes. It reflect back. So like this. And coming to the fourth one. So pole, focus, center of curvature, pole, focus, and center of curvature. Light rays incidenting at the pole. So it reflect back. So 1, 2, 3, 4, 4. These are the 4 ray rules of convex mirror. Okay, so next one we will discuss about image formations. Okay, so image formations of concave mirror. So image formations of concave mirror. Next, image formations of convex mirror. So after that, lens will discuss. Okay, so first one I'm taking concave mirror ray rules. Sorry, image formations, concave mirror. So first one I'm taking here. So pole, focus, center of curvature, pole, focus, and center of curvature. Object is placed at infinity. So how many light rays? 1 or 2 light rays I'm taking. One light ray like this. Another light ray I'm taking here. After reflection, the light rays are meeting at one point on the print on focus. So here these light rays will meet here. Okay, object is at infinity. Image is forming at focus. Nature of the image is real and inverted, and size of the image is highly diminished. And coming to the second one, so pole, focus, center of curvature, pole, focus and center of curvature. Object is placed beyond center of curvature. How many light rays are required to form the image of the object? Minimum 2 light rays. So one light ray I am taking like this. So after reflection, the light rays passes through focus. Another light ray is passing through center of curvature. So the image will form between C and F. Image will form between C and F. So here the image will form. Object is placed between beyond C. Object is placed beyond C. Image is forming between C and F. Nature of the image is real and inverted, and size of the image is diminished. Size of the image is diminished. So that is second one. Coming to the third one, this is second one. Coming to the third one. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at C. So object is placed at C. So one light I am taking like this. So it is passing through another light ray. So here it is passing. So here it is passing through. So here this is a focus. So another light ray is incidenting at the pole. It reflects back. So here you can observe. So object is placed at C. Image also is forming at C. Nature of the image is real and inverted. And size is same size. Object is placed at C. Image also will form at C. Nature of the image is real and inverted. Size of the image is same size. These are the three. Next one. Object is placed between C and F. Image is forming beyond C. Nature of the image is real and inverted, and size of the image is enlarged. Compared to the object, image size is increased, enlarged. Coming to fifth one. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at F. So one lighter I am taking like this, it passes through focus. Another lighter is incidentally at the pole, it reflects back. Object is at F. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. And coming to sixth one. So I am taking here likewise. So pole, focus, center of curvature. Pole, focus, center of curvature. Pole, focus and center of curvature. So object is placed between F and P. Object is placed between F and P. One light I am taking like this. So it will be reflected. Another light ray. So if you are extending these light rays will meet here. Extended light rays. So object is placed between F and P. Object is placed between F and P. Image is forming behind the mirror. Nature of the image is virtual, erect and enlarged. So this is about convex, so concave mirror image formations. Next we'll discuss about convex image formations. Only two cases are there. Convex mirror. So pole, focus, center of curvature. So object is placed at infinity. So two cases are there, right? Object is placed at infinity. Object is placed at infinity. So one light object is placed. So I'm taking here. Passes through focus. Object is placed between infinity and pole. Image is forming between P and F. Nature of the image is virtual, erect and diminished. Virtual, erect and diminished. Okay. So next. So mirror formula 1 by F equal to 1 by V plus 1 by U. And magnification equal to height of the image by height of the object minus U by U. Minus V by U. So that is about magnification. So thank you so much. Do like, share and subscribe to Student in the Brand if you like the content, if you like the channel. So you can subscribe and share to your friends. Thank you so much.